Hi, Quaid and I are researching what your brain does when you see optical illusions.
First, let's show you some optical illusions.
What is this a picture of? If you said rabbit, you're right. If you said duck, you're also right. The person who drew this made it look like it could be a duck or a rabbit. Sometimes you can see both.
See these circles? Look around the image. Are the circles moving? They are moving because when you look at it, your brain is trying to find the easiest way to perceive it. The black and white lines help to make the circles look like they're moving.
Does this image look like it's spinning? Focus on one spot and the rest of the image will keep moving. Why? Because the white and black lines take control of the shortcuts in your optic nerve.
These wavy lines are not moving. Just move your eyes around the image. Again, it is taking control of the color shortcut, which you will learn about later.
Read the words. There's nothing wrong with them, right? Read it again. There's two thes. The reason you don't see it the first time is because your brain likes to make shortcuts, like I said earlier, and it sees the other as unimportant.
Which inside circle is bigger? They are actually the same. When you place bigger circles around one and smaller circles around the other, it makes them look different. Which man is the biggest? The one on the far right, right? No, they're all the same, but the lines make them look bigger than they really are. Is the girl on the right smaller? No. The ceiling is slanted, and the room is deeper on the right side, so this image is affecting your perspective.
When you see something, you are really just seeing the light that is bouncing off of it.
The light is then turned into electrical signals that your brain turns into an image.
The cerebral cortex is the thin layer that covers the outside of the cerebrum.
The cerebrum is the most highly developed part of our brains. It is responsible for perceiving, producing, and understanding language.
Your brain uses shortcuts such as color, perception, and shadows to create the image you are seeing without as much work.
The brain uses the raw data of light wavelengths, then it puts the picture together.
So in other words, your brain uses the light wavelength to make the image of what you see.
Our brains use shortcuts so that we don't have to take everything in, only the important stuff.
Lots of these shortcuts happen in our optical nerve. The optical nerve sends information that it receives from the retina to the brain through electrical impulses.
Our optic nerve receives signals from about 125 million photoreceptor cells. That means that there's a lot of room for the optical illusions to affect your optical nerve.
The optical nerve is also called the second cranial nerve.
So, when you see something, it's just light bouncing off of the object that you're looking at. Then it is taken to the cerebral cortex, where that image is made into a picture, and that process is done in 1/10 of a second. So, that is why you see things in real time. The cerebrum is where all things are heard and perceived.
The optic nerve is an easy target for optical illusions because it has lots of room for mistakes between electrical impulses and the 125 million photoreceptor cells.
Yo, it's been really fun filming this, and I'm glad it's over. Just kidding. Now you know that optical illusions are just a prank, and there's no need to stress over them.
Thanks for watching, and please subscribe. If you don't, we'll kill you with optical illusions.